WS S03N servo connected up to the MyRio connector B. The VI is running. Here's the main input that commands the servo to a particular position. Here's the details of the pulse width modulated signal that's being fed as the command input to the servo. We can control the frequency, and then we can also observe the corresponding pulse width. So I've nudged it a little bit. Here we see we're using a higher pulse width. "100% corresponds to 2 milliseconds. And minus 100% corresponds to 1 millisecond. And again, 0 is back to 1.5 milliseconds. You can adjust this if you like to use another pulse width modulated output channel on MyRio. You can also experiment with the frequency, that is the repetition rate. Here we see it acts kind of funny. This is because it's too low. All right, working a little better with 50 hertz. Let's try a faster rate. Clearly 200 hertz was too fast. 50 hertz is the recommended frequency, and that gives us a pulse every 20 milliseconds. Note that the servo is not quite at 0 degrees even though I'm applying the neutral pulse. Let's try some fine motion here. You can single step with the page up and page down keys. What I'll do is align the servo to the desired position. This is straight up and down. Next, press the null offset button to save an offset and then release the button. And from now on, when you enter 0 for the position, the servo goes precisely to that 0 position. Alright, let me stop the VI and start to take a look at the construction of the block diagram. Outside of the while loop, we open a channel to the pulse width modulated output. And again, you can pick from a number of PWM outputs that are available on MyRio. This VI is located under the Advanced I/O subpalette under PWM, and there's open right there. We have some others where you can manipulate the duty cycle and frequency. You can close the channel, and you can also set the duty cycle and frequency independently. Alright, our main position control is located right here. The position adds an offset, or what we call the null offset. When the null offset button is true, then the position is fed into this feedback node, and that is equivalent to a shift register on the while loop. When null offset is false, then we pick this side and we simply recycle the previously stored value of null offset. The initial value is 0. Pass through a little bit of math calculations, and then eventually we have the frequency and duty cycle specified for the PWM output. Looking at the air cluster, we OR the air cluster together with the stop button on the front panel. Either one of those conditions being true sends us through the simple air handler, and then we execute a MyRio reset. Here I'm also pacing the loop at 10